Hey everyone, and welcome. Have you ever looked at a single number, like a test score or a sales figure, and just wondered what it really means? Well, today we're going beyond the average to figure out where one data point actually stands in the middle of a crowd. It's a fundamental question in understanding data, so let's dive right in. All right, let's kick things off with a super relatable scenario. Imagine you just got a test back and you see the number 75. Now, what's your gut reaction? Are you happy? Disappointed? The real question is that even a good score? How can you possibly know? Because here's the thing, that 75 all by itself is pretty much meaningless. It's just a number floating in space. I mean, if the class average was a 50, you're basically a rock star. But if the average was 95, well, that 75 starts to look a little different, doesn't it? It all comes down to context. So how do we get that context? Well, that's where a really cool set of statistical tools comes into play. They're called measures of position, and they're all about, you guessed it, slicing up your data so you can see exactly where any single value fits into the whole picture. So what exactly are these things? Well, measures of position, and you might hear them called by their fancier names, quantiles or fractiles, are really just specific points that chop a whole data set into equal-sized pieces. This is what lets us finally see the true rank or standing of one value compared to all the others. And this diagram right here, it lays out the whole idea beautifully. You can take your data and just slice it in half with the median. Or you can get a bit more detailed and cut it into 4 equal chunks. Those are called quartiles. Want more detail? Slice it into 10 pieces with deciles. And for the most precision, you can slice it into 100 tiny pieces using percentiles. Okay, so let's ease into this by starting with the most common and honestly the most intuitive way to slice things up, breaking our data down into 4 equal quarters. Let's talk about quartiles. Now, the key thing to get here is that quartiles aren't the 4 groups themselves. They're the 3 specific points that do the dividing, creating 4 buckets with exactly 25% of the data in each one. And you know what? Finding them is actually super straightforward, especially for a simple list of numbers. Step 1, you just arrange all your data from the smallest value to the largest. Then you find the number that's smack dab in the middle. That's your median, also called Q2. From there, you just find the middle of the bottom half. That's Q1, and the middle of the top half. That's Q3. That's it. Let's put this to the test with a real-world example from a coffee shop. So we've lined up the number of customers they had each hour. The median, Q2, is right in the middle at 10 customers. Now we look at the bottom half, and its middle value, Q1, is 9. And the middle of the top half, Q3, is 14. This tells us something really useful. 25% of the hours, the shop had 9 or fewer customers. See, we're already getting so much more insight than a plain old average could ever give us. All right, quartiles are great for a quick overview, but what if you need to get a little more granular? What if you need more precision? Well, that's where deciles and percentiles come into the picture, letting us make much finer slices. It really just comes down to this simple breakdown. Quartiles give you 4 big chunks. Deciles chop the data into 10 equal parts, which is perfect for when you hear about being in the top 10%. And for the ultimate level of detail, percentiles slice your data into 100 tiny parts. Here's a classic example you might see on a standardized test report. It says, Mikasa got a score of 55, which is equivalent to the 70th percentile. So what on earth does that actually tell us about her score of 55? See that? That phrase right there, 70th percentile, that's the magic key. That's the piece of context that gives her score of 55 all of its power and meaning. It tells us exactly how she did compared to every other person who took that test. So, what's the translation? It's simple, really. It means that her score, whatever it was higher than 70% of her classmates. It also means that 30% of the class scored the same as her or even better. All of a sudden, that number 55 isn't just floating in space anymore. It has a story. Okay, so all of this is pretty easy when you can see every single number laid out in front of you. But what happens when you have a ton of data, so much that it's all just bundled together into groups or ranges? You get something that looks a little like this. This is called a frequency distribution table. We can't see the individual scores for all 50 students. Nope, all we know is how many students scored within a certain range. For example, we know that 11 students scored somewhere between 36 and 40. So that's the big question, right? If your score was, say, a 38,
How in the world do you figure out your percentile when you're just lumped in with a group of 10 other people? How do you find your exact spot in this big crowd?
Well, here's the good news. The goal is exactly the same. We still want to find our relative position. But because we can't see the individual numbers, we can't just count our way there. We have to use a slightly different approach, a formula that helps us estimate our position within that group. And to do that, we just need a couple of key ingredients. First up, we need something called the lower boundary, or LB for short. So if you scored that 38, you're in the 36 to 40 group. The lower boundary is basically the precise starting line for that group. Think of it as our anchor point to start our calculation. And the other key ingredient is the cumulative frequency below. It sounds complicated, but we'll just call it CFB. All this is a simple count of every single person who scored in all the groups below the one you're in. It tells us the total number of people that you have definitely scored higher than, which is a huge piece of the puzzle. All right, so we've gone from simple quartiles all the way to tackling grouped data. Let's pull back for a second and ask the big question. Why does any of this matter? Why is knowing your position so incredibly important? The bottom line is, these measures of position tell you so much more than a simple average ever could. They give you your specific rank, your standing. They provide that critical context we've been talking about this whole time. They even give you a feel for how the data is spread out, letting you see instantly if your score is pretty common or if it's truly exceptional. And that, right there, is the real magic. An average just gives you a blurry, fuzzy snapshot of the center of your data. But understanding position, that's like having a high-resolution map, turning a single, lonely data point into meaningful, actionable information. So I want to leave you with this final thought. We've seen today how the simple, everyday average can be pretty misleading and hide the real story. So my question to you is what? What other common stats that you see all the time might be giving you a simple answer, but not the whole truth? Thanks for watching.